Okay, so we're still solving quadratics by graphing. So we're going to look for the vertex and things like that, but now they have word problems. So here in this one, it says, Sam kicks a soccer ball up in the air. We're going to want to make sure we have one of our calculators. I got to make sure I get my calculator going on the screen up here. But Sam kicks a soccer ball up in the air with an initial velocity of 64 feet per second. The ball is 2 feet above the ground when it's kicked. This is the equation. Now, what's nice is they just, in these problems, I'm going to give you the equations. You're going to be given the equation just like you were in the other one, and then you're going to be asked some questions. So here, h equals negative 16t squared. T is the time in seconds that it's in the air. But what we're looking at, t is the same as x, and h is going to be the same as y. So this is just y equals, but it's the height at a certain time. So if you take your Inspire calculator, or if you're at home, use your Desmos. We got to add, we got to add a graphing page. So y equals, and on this one, it has negative 16t squared. We're going to put x squared plus 64x plus 2. Now that 2, it said that, you know, the ball is 2 feet above the ground when kicked. I mean, so you kind of picture, here's the soccer ball, here's the person going to kick it. Okay, and the ball is 2 feet above the ground. When they kick the ball, it's 2 feet above the ground, and then it's going to fly like this, and at some point, it's going to land. Now, this here would be its maximum height. That would be the vertex. Does that make some sense? Okay, so this is kind of the picture that we're dealing with, but our calculator does it for us, and we draw, and it doesn't quite look the same. But remember, I taught you a function, the zoom fit to the screen. So we're going to try that again. We're going to go menu number 4, zoom, and then it's A, fit to the screen. And now it's getting a little bit better. Now here's the idea. Up here, the ball is kicked, and when it lands over here. It's just, we have this whole big graph. Now I'm going to change something. I'm going to have us try something here. You see down here where it says like negative 2400? Can you click into that and back up and delete that? And then try to make that negative 5 and hit enter. And it's going to change your graph quite a bit. That's all that pops up. Okay, try it again. Okay, so everybody, here, let's try this again from the start. Those having difficulty, let's press the on button. Let's go new document. Do I want to save? No. Number 2, I want to add graph. Now, use the negative button. Negative 16x squared plus 64x plus 2, then hit enter, and you should see something like that. That's the graph. Okay? Did you get it this time? Didn't work? Bring it back. Let's see. Show me what you're hitting. Here, just type it in. It's some button you must be hitting wrong. X. Squared. That's one. Plus 64x. We're replacing t with x. Plus 2. Don't put in t. We're not putting in t. We're putting in x, right? It's y and x. We're replacing those. So now, do it work? Okay. So now everybody, menu 4A. Now go to the bottom here and you want to click into this box. You see where it says negative 2400. Click in there. Delete that out and let's make that negative 5 and then hit enter. This is our graph. Here's the idea. He kicks the ball here 2 feet in the air. It goes up, it hits the height, and then it comes back down. So now we're going to answer some questions. Does everybody have what I have on here, basically? All right. So one of the questions says, what's the ball's maximum height? So we're looking for the top or the vertex. Is it a maximum or a minimum? Maximum. So we're going to go menu, 6, 3. And we're going to click on either side, and you'll see the maximum height is 66 feet in the air. Kicks the ball 66 feet in the air. So 66 feet. And you're like, well, why isn't it the 2? Here's what the deal is. The 2 is how many seconds. That's the time, and this is the height. So how long will it take it to reach its maximum height? 2 seconds. That's what the 2 stands for. Now, when will the ball hit the ground? The ball hits the ground only in one place. It doesn't hit it over here. There's only 1 0 we're worried about. So we have to find the 0 that's over here on the right. So we're going to go menu, 6, 1. And I'm going to click over here, and then I'm going to drag until this 0 shows up. And this 0 shows up, it says at 4.03 seconds. So it's going to hit the ground at 4.03 seconds. Now the domain and the range. Domain is for the first time going to be different. The domain is from 0 seconds to 4.03 seconds. You're like, what? Why isn't it all real? Because when he kicks the ball, 0 seconds is the start. And when it hits the ground, that's when it ends. And that's the whole domain. So X is only from 0 to 4.03 seconds. Now, what's the range? The range, the lowest the ball will ever be is 0. Now, it actually hits 0 here for the first time. But what's the highest it got to be? What did we say was the maximum? 0 to 66 feet. So this is a little bit different than anything we've done with the domain and range before in this type of problem. But it's not hard because we understand domain's the X, range is the Y. All right, so now let's go to the next one. During halftime of a basketball game, a slingshot launches T-shirts at the crowd. So I'm kind of picturing they've got this slingshot thing. They put a T-shirt in here. Now it's probably all bundled up, but I'm gonna make it look like a T-shirt. Okay, and it launches it up in the air. Okay, now this is the ground level. The T-shirt is caught 35 feet above the court. Interesting. We want to know the T-shirt's maximum height. So first, let's put this equation in. So everybody, let's go new document. Don't want to save. Number 2, want to add graph. -16 x. Now we're using x instead of t. X squared plus 72x plus 5. Now the t-shirt was launched 5 feet off the ground. It's caught at a little bit higher. This should probably be a little bit higher. But we're still looking for the t-shirt's maximum height. So when we graph this, again, the same thing happens. So we're going to go menu 4A, which is the zoom. And I don't like this picture of it all. So what I want to do is I want to get rid of a lot of this stuff on the bottom. So we click into this box down here, way down at the bottom. Move that a little bit. And you got to click into this box. Can't get in there right now. There we go. And I'm going to make it -5. So now here's the idea. It's launched in the air, and again, it lands. Okay. What's the t-shirt's maximum height? That is the maximum. So menu 4, not menu 4, menu 6, 3, our maximum is at 86 feet. How long does it take to get there? What does it say? 2.25 seconds. You're like, what's that? Well, just think of seconds. 1, 2, 3. It's a little bit after the 2. 1, 2, maximum height, 3. How long after it's launched will it be caught? Now this, we have to add something else. Somewhere up here, it has to be caught. So this, it doesn't hit the ground this time. So we're going to press the tab button. And when you press the tab button, you can add another equation. So the other equation I'm going to put in there is 35. Just 35. Everybody put 35 and hit enter. Now see this new line, where this new line crosses right here where my mouse is hovering, that's where it's caught. It's caught 35 feet in the air. Does that make some sense? We have to figure out that intersection. So this is something new. We're going to go menu 6, 4, and we're going to find our intersection. Now we need a lower bound, upper bound. Everybody, this is the dot I'm trying to get. So I'm going to click here and I'm going to drag over. Do you see something show up, an intersection? And it says at 4.04 seconds, how many feet in the air? 35, which is how many feet it's supposed to be caught. So after how many seconds is it caught? 4.04 seconds. What's the domain and range? 0 to 4.04. The range. Now the range is not 0 because it never hits the ground. It is at its lowest point 5 feet off the ground, and it ends up 35 feet off the ground. So 5 is its lowest. What was its highest? What was the highest? 86. So 5 feet to 86 feet. Okay, there should be a worksheet on here. 9.2 day 3 is the, I think, the worksheet you should have. No, 9.2 day 4. And that's it, but that's not the one I want. 9.2 day 4, I don't want the one with the answers. So I want to do one of these. On here, there are 4 problems. We're going to start out, we're going to look at number 1. I'm going to continue to video record yet, so anybody at home can do one of these problems. Okay. So a ball is thrown in the air. It gives us an equation. Let's take our calculator. If you haven't caught on yet, hopefully you are. Let's press the on button. Let's go new document. Let's not save. Let's add a graph page. So this is just like, I mean, the one way it's like the last lesson, it's just like it because we're solving with the calculator. What's different now is they're using height and time, but we're still going to use y and x because the calculator uses y and x. So remember, this is y, and all those t's are x's. So again, let's go negative 16x squared plus 12x plus 5. And something went wrong for me. I did not square the x, so I'm going to go back up. If you make a mistake and you hit tab, you can go back up and you can fix it. And there's my graph. Now this one's a little nicer. I am going to go menu 4A and zoom in a little. And I don't like that it went so low. So again, down here on the bottom, I'm going to back that up and I'm just going to put in -5. You might say, well, why -5? Now that one's still even kind of goofy. So sometimes what we're doing is we're fitting the window different, if that makes sense. So let's look up here. I think this is way too tall. To me, maybe it only has to go 10 or 20 tall. It's going 178 in the air. So let's click into that box. I went -5 on the bottom, and up on the top, let's change that to +10 and see what happens. That's pretty good. Now you can click in any of these boxes. Maybe you don't want this -10. Maybe you only want that to be at -1. That's not bad. Maybe you don't want this box at 10. You can click out there. Maybe you only want that at 5 seconds. That's a pretty good graph. Okay? So you can play with that, but you got to be able to click into those different boxes. It's really not that bad. Now, up here, we have to find the maximum. As long as you see the maximum, it doesn't matter if your window is the same as mine. We're going to go menu 6, 3. Now, today, everything's going to be a maximum because it's things going up in the air. So picture it. Something goes up in the air like this. It hits a maximum and comes back down. Those are all these story problems. So we're not going to find a minimum where we like kick it up down. Does that make sense? Because if you kick it down, it hits 0 because it hits the ground. And it's always going to have, you know, a ball or a rocket ship or something like that flying through the air. All right, so this one, what is on this one? How long does it take to hit the maximum height? How many seconds? Not very many. 0.375. What is the ball's maximum height? So 0.375 seconds. So if you think about that, 0.375 is like 1 second. You know, count to 1. It's not even a half a second. And then this was 25 feet in the air, not very high. But now when will it hit the ground? It hits the ground over here. Well, we got to find out when. So we're going to go menu 6, 1. We're going to find what we call a 0. Click here and drag it over till that 0 shows up. And it looks like it hits 0 at about 1 second. 1.05 seconds. Now, what's the domain? The domain starts at 0. Why? 0 seconds. And it ends when the ball, is this ball? Yeah. When the ball hits the ground. What's the range? Since the ball starts in the air and lands, the lowest it ever gets is 0. And the highest it ever gets is the maximum, which is the 7.25 feet. The domain is in seconds. The range is not. We'll end that with the video. We can do one more together. Okay.